Hi everyone, thanks for stopping by, the interest in the channel, contributors, the support. Guys, this is the constellation of Virgo. We're talking exoplanets, galaxy clusters in abundance. We're talking deep space, Messier objects. Beautiful photos that I got. All the photos on this channel are taken from me, and in this video too, they're all from me. They're of deep space process photos of the constellation of Virgo. Just beautiful. Guys, I got photos of galaxy clusters. I got photos of galaxies um, as close as I could, and it's just mesmerizing. I'll share them with you. And there's a lot of amazing facts about the constellation of Virgo that we have to take note of, and I'm like, wow, overwhelmed by the information of the exoplanets in the constellation of Virgo. Guys, there are 35 verified exoplanets orbiting 29 stars in Virgo, including PSR B1 257 plus 12. Three planets around that star. 70 Virginis is one planet. Chi Virginis, one planet. 61 Virginis, there are three planets. Two planets around NY Virginis, and 59 Virginis, there's one planet. There are deep space objects because of the presence of a galaxy cluster, consequently called the Virgo cluster, within its borders of 5 degrees to 12 degrees west of Virgo, Vindimiatrix. This constellation is especially rich in galaxies. Imagine a constellation rich in galaxies. It's absolutely amazing. The constellation is especially rich in galaxies. Some examples are Messier 49, elliptical Messier 58, spiral galaxy, Messier 59, elliptical Messier 60, Messier 61. It doesn't end. 84, 86, 87 are all in Virgo cluster. Messier 89, Messier 90, and of course, the brightest star in the constellation, they say Spica. Spica is 250 light years away. Now, guys, when we say light years, years has actually nothing to do with the amount of time. It's a term when we're talking about galactic terms in astrometry and when we're calculating long distances. But don't be mistaken when we say light year. So, yes, exoplanets, guys. There are a lot of planets inside of this constellation, the constellation of Virgo. Booties over top, of course, bordering other Leo on its side. It's between Libra, well, actually, Leo to the west and Libra to the east. This is the second largest constellation in the sky after Hydra. It can be easily found through its brightest star. Spica is actually not just one star, so we'll find out more about the information. I mean, the bright star Spica makes it easy to locate Virgo. It can be found by following the curve of the Big Dipper Plough to Arcturus in Bootes, and continuing from there in the same curve, you follow the arc to Arcturus, and the expression they say in speed on to Spica, of course. Um, Here's something very interesting about the star, like everyone says, Spica. Everyone thinks it's a star. First of all, it's not a star, okay? It's a spectroscopic binary and rotating ellipsoidal variable, a system whose two main stars are so close together they are egg-shaped rather than spherical and can only be separated by their spectra. The primary is a blue giant and a variable star of the beta Cephei type. Now, guys, egg-shaped. The moon is so close to Earth. Is that why it's egg-shaped? Probably so, when you think of it. Just little things that I like noticing, which is very interesting. No, there are so many interesting things about the constellation of Virgo. And guys, I am going to show you many, many odd and peculiar stars and peculiar galaxies, which is a term, by the way, galaxies that are out of the ordinary and oddly shaped and have many gases floating around in it. We're going to see lots of photos of astrophotography that I took of deep space. They're beautifully processed. Wait till you see them. I can't wait for you to see them all. I hope you enjoy them and appreciate them. Guys, I'm trying to raise money for a bigger telescope. Those who can and that are interested, and this is why I started the fundraising campaign, because some were interested in really seeing what is out there and they really believe in their hearts that there is something out there, as I also do. So I'll have a link up in the description to myevents.com where I am posting a page of my link. Guys, thanks a lot. Variable stars, beta Cephei type. Guys, there's so many terms we have to look up. Triangle, it's the spring inside of the spring triangle asterism. That's where it is, Svika. Now, guys, this is absolutely amazing. The information about the exoplanets that are there is absolutely incredible, too. The amount of exoplanets that were found um, just from 1988, we're talking about a handful of planets, a handful, guys, and we're up over 4,000 planets, if not five, that were found now by both HARPS, NASA, Hubble. They've all been confirmed. That amount, can you imagine? Black holes and spiraling galaxies, guys. I was able to get pictures of this. It's just absolutely amazing. And you know what? What's going on is that astronomers are saying massive black holes are about to smash together in space, and astronomers are watching the flashing lights and taking in the signs. That is, Columbia University researchers recently published their evidence and conclusions about this in the journal Nature. In that research, the team found that the two black holes are the source of rhythmic light flashing from quasar PG 1302-102. Quasars, by the way, are the brightest objects in the universe, and they are powered by black holes. In this case, the quasar is lit up by two black holes, according to a release. It's not because they call them black holes that they are black voids that you cannot see. Some are very bright because everything happens at a different pace in space. The smash up, they say, is to happen in 100,000 years from now, say the researchers. That's a very short time in space time, though, as the scientists noted in the release. Currently, the black holes are 3.5 million light years from Earth and are within the Virgo constellation. They are also much closer together, only a light week than the last confirmed black hole pair, which were separated by 20 light years, the release said. This is the closest we've come to observing two black holes on their way to a massive collision, said Zoltan Heyman, an astronomer at Columbia who is senior author of the study in the release. Watching this process reach its culmination can tell us whether black holes and galaxies grow at the same rate and ultimately test a fundamental property of space-time, its ability to carry vibrations called gravitational waves produced in the last, most violent stage of the merger. Just what exactly are black holes? It can't be seen. We're talking about dark matter. And NASA says a black hole is a place in space where gravity pulls so much. Imagine gravity pulls so much that even light cannot get out because there is too much gravitational pull on what is going on in that area that even the spectrum of light is not able to evacuate out of this area, that everything is squeezed into a tiny area. The gravity is so strong because matter has been squeezed into this tiny space. It can happen when a star is dying because no light can get out whatsoever. And this is why people can't see black holes. Yes, black holes, they are a region of space-time exhibiting such strong gravitational effects that nothing, not even particles and or electromagnetic radiation such as light, can evacuate from it. It remains stuck inside of it. The theory of general relativity predicts that a sufficiently compact mass can deform spacetime to form a black hole. The boundary of the region from which no escape is possible is called the event horizon. Although the event horizon has an enormous effect on the fate and circumstances of an object crossing it, no locally detectable features appear to be observed. In many ways, a black hole acts like an ideal black body, as it reflects no light. Moreover, quantum field theory in curved spacetime predicts that event horizons emit Hawking radiation, with the same spectrum as a black body of a temperature inversely proportional to its mass. This temperature is on the order of billionth of Kelvin for black holes of stellar mass, making it essentially impossible to observe. Objects whose gravitational fields are too strong for light to escape were first considered in the 18th century by John Michell and Pierre-Simon Laplace. The first modern solution of general relativity that would characterize a black hole was found by Carl Schwarzschild in 1916. Very interesting, and it's actually something that's pretty scary because black holes of stellar mass are expected to form when very massive stars collapse. So we do know that stars are collapsing, even though they are far away at the moment, at the end of their cycle, in their life cycles. After a black hole has formed, it can continue to grow by absorbing mass. It eats mass from its surroundings by absorbing other stars and planets and merging with other black holes, supermassive black holes of millions of solar masses. They can form. There is general consensus that supermassive black holes exist in the centers of most galaxies. Despite its invisible interior, the presence of a black hole can be inferred through its interaction with other matter and with electromagnetic radiation such as visible light matter that falls onto a black hole can form an external accretion disk heated by friction, forming some of the brightest objects in the universe. If there are other stars orbiting a black hole, their orbits can be used to determine the black hole's mass and location. See, this is what's going on in the constellation Virgo and what NASA and scientists are doing right now. Such observations can be used to exclude possible alternatives, such as neutron stars. In this way, astronomers have identified numerous stellar black hole candidates in binary systems and established that the radio source known as Sagittarius A at the core of our own Milky Way galaxy contains a supermassive black hole of about 4.3 million solar masses. That is huge. So what's going on is, yes, there are several black holes in our universe that we can't see that they are now finding and able to, I imagine, detect in other ways through science, etc. But yes, they're massive black holes, and it's consuming mass. So it's taking in, it's eating in all these planets, stars, galaxies, and the black holes are also interacting, imagine, with other black holes, and the universe is totally amazing. It's huge, and what's going on is it's mind-boggling, and there's so many things going on, and it's absolutely impossible for us or anyone to stop any of this, but coming to understand some of it can save us here on Earth in the future for either asteroids coming to Earth, and it tells us about the universe. It tells us where we're from, why we are here by studying the stars. Why do you think we've been studying the stars for thousands and thousands of years? I hope you enjoyed this video on the constellation of Virgo. These were deep space astrophotography photos that I took with my 1000 millimeter camera and magnification technique, using it to be able to get nice and close on the images to show you a virtual view of the constellation of Virgo from May 20th, 2017. Guys, thanks a lot. I'll have the link up for the campaign to get the bigger telescope in the description of the video. And thanks for watching, everyone. I'll see you in the next video. Now, some people are trying to crash my link campaign. Well, you can't, guys, because it's legitimate. It's a company in Montreal, myevents.com. But doing donations, some idiots, I guess, donated with fake credit cards, or I have no idea. But don't worry, the amount jumped way down to $1,889 as compared to, oh, I don't remember, I think it was 2,399. But I have no idea why it did that, because see, that looks bad, seeing my amount go from higher to lower, and some people are trying to discredit me, but it's not going to work, and the money's going to come in. So we're raising that money to get a bigger telescope, the $9,000. So if you see my amount go up to $4,000 and then drop suddenly, don't wonder why. One of my donors was magnificent, sweetheart, was able to call me up, message me, actually email me, and tell me, Bruce, just to give you a heads up that myevents.com called me to see if I had really given money, and I told them I did, and they said we were just confirming it. So I guess they must have confirmed many donations that were bum donations. But anyways, we have the 1889 anyways. I'm ecstatic about it. These names are still up. I went to see on the campaign, and it's all legitimate donors. Thanks, guys. I love you. So a few of the anonymous ones were trying to uh, fake things, and I did get some real anonymous donations also. So yeah, it's just sad that the world's like that. Get sad, pathetic, despicable people. But this channel ain't gonna disappear. It's gonna get bigger and bigger. So thanks for the support, guys. Check out the link in the chat and the video description. And for those who can contribute, go right ahead. I greatly appreciate it. And thanks for joining the channel, guys. Thanks for being a part of the community.